So when you're doing, when the speaker is talking about, or when the speaker is delivering the talk, I would like to ask all the participants to mute your speaker, so you can just press the audio sounds button there, so that it will avoid the noise from the background. And if you have any questions relating to the topic, you can actually type your questions on the chat box there, and our speaker will answer your questions after the talk. So that's just the two rules that we're going to have for this webinar.
Just to add up a little bit from what Ria has said. So the first 30 minutes, around 30 minutes, will be Qin to talk about her presentations, and then another 30 minutes will be question and answer for you guys. If you don't feel comfortable to ask questions in English, you can just ask question in bahasa. Jadi kalau yang tidak nyaman bertanya dalam bahasa Inggris, tanya saja dalam bahasa Indonesia. Either Ria or I will help you to translate your question so Qin can answer that. Another thing, I'll record these presentations because some other people might want to watch it later and they cannot make it today and then probably want to watch it later. So basically, I'll just share this presentation from today for them as well. So yeah, I think that's it. And if you have questions, any questions, feel free to just ask it. There's no stupid questions. So even if it's a simple question, just ask the questions, and Qin will help you to answer that. Okay, so I think I will give time to Qin to talk, but I'll go to her and then have her a bit. Okay.
Hello, my name is Qin. I'm originally from China, so I can't speak Indonesian. And Elva's helping me to share the screen. Is it that button?
Yeah, I think.
Yeah. Start sharing. Okay, good afternoon or good morning, Indonesia. Welcome to Stat 101. My name is Qin, obviously you know, and I'm a PhD student at University of Tasmania in Australia. Today, I'm going to talk about a bit about probability. So we use probability in daily life to make decisions when we don't know for sure what the outcome will be. For example, today before you go out, you might wonder if it might rain later, and you probably want to decide you need to bring an umbrella with you or not. So you check your weather forecast app on your phone and you found out that 20% of rain today. Well, you might think the chance of raining today is quite low, 20%. So there's no need to bring an umbrella with you. So we call the chance of raining is the probability of raining. So what is a probability? Well, it is a number. This number describes how likely something is going to happen. And always remember that a probability Can you hear me? So where am I? A probability is bounded between 0 and 1. You can never get a negative probability, and you can never get probability that is greater than 1. Yeah, and speaker, can you still hear me? Yeah, good. Okay, now I'll keep going. This is a number line between 0 and 1 showing that a various probability. That when the probability is 0, that means this event is impossible to happen. For example, I can say that you can't fly today. You have no wings. So the probability for you to fly today is 0, impossible. And we can get an unlikely event to happen that is, we have a really low chance for this to happen. This number may be 20%, 30%, we call it unlikely to happen. And we can have an even chance of something to happen. For example, you flip a coin. The chance of getting a head and the chance of getting a tail is equally likely, like 50% you might get a head and 50% you might get a tail when you flip a coin. And you might get something quite likely to happen. For example, if there's a box with 5 balls.
Kali ini kan sebenarnya saya terkesan sekali sebenarnya sama 2 orang anak di umur SMP sudah.
I'm going to keep going. For example, if there's a box full of, there are 5 balls in a box and 4 green balls and 1 red ball. The probability for you to pick out a green ball out of these 5 balls is quite high. So this event is quite likely. And we can also have probability something to happen equal 1. We can be certain that something's going to happen. For example, if your birthday is 9th of March, then I can say that tomorrow is going to be your birthday. 100% is going to happen. So this is probability. Now let's look at the formula of a probability. So the probability of an event is calculated as the number of ways it can happen divided by the total number of outcomes. So I have 2 simple examples to show you, illustrate this formula. For example, when you flip a coin, what is the probability of getting a head when you flip a coin once? So when you flip a coin once, you can either get a head or a tail, right? So the total number of outcomes is 2, either a head or a tail. And the number of ways you get a head is only 1. You flip a coin, you can either land on a head, so only 1 way. So the probability of getting a head when you flip a coin once is half, also equal to the probability of getting a tail. Another example is rolling a fair die. So when you roll a die, a 6-sided die, the total number of outcomes can be 1, 2, 3, 4, 5, or 6. So the total number of outcomes is 6. What is the number of ways you can flip a 1? It's only 1 way, just this way. So the probability of getting a 1 when you roll a fair die is 1 on 6. So this is probability. Now I'm going to talk about 2 probability problems. One is the Monty-Hall problem, and the other one is the birthday problem. So here's the Monty-Hall problem. Imagine that you are on a TV game show hosted by a person called Monty-Hall. The rules of the game are, there are 3 doors, door 1, door 2, and door 3. And behind one of these 3 doors, there is a car. And behind the other 2 doors, there are 2 goats, 1 goat behind each door. So if you selected a door that there's a car behind it, you got a car. If you select a door, there's a goat behind it, well, you get nothing. So the host, Monty-Hall, says, let's make a deal. Please select a door. Then you select a door. After you selected the door, Monty-Hall will open one of the remaining 2 doors revealing that it does not contain the car, then Monty-Hall will ask you, would you like to switch your selection to the other unopened door? Or would you like to stay with your original choice? What would you do? Do you switch or do you stay? Does it matter if you switch? Have a think about it. Okay, I'm going to explain to you this problem with two different ways. One way is use the slide. This might be a bit confusing. And later on, I'm going to explain this problem with 3 cups. Let's look at the probabilities of switching and staying. Let's say that there are 3 doors, door 1, door 2, and door 3. And you chose door 1 at the start. So the total number of possible outcomes are 3. We can have a car hidden behind door 1, or we can have a car hidden behind door 2, or we can have a car hidden behind door 3, right? Let's consider scenario 1. You always chose door 1, okay? You chose door 1. The car is behind door 1. And the Monty-Hall going to open door 2. It doesn't matter, he opens door 3 as well because there's nothing. He knows there's a girl behind one of these doors. So it doesn't matter which door he opens. He opens door 2. Say, oh, look, there's nothing. There's a girl behind door 2. Are you going to stay or are you going to switch? In this scenario, if you stay and you win. If you switch, you lose, right? Scenario 1. Let's move on to scenario 2. This time, the car is behind door 2. You chose door 1. Okay, Monty-Hall say, look, I opened door 3. Look, there's a girl behind door 3. Are you going to stay or are you going to switch? Well, in this scenario, you better switch, right? If you switch to door 2, you got a car. If you stay, you lose. Let's have a look at the last scenario when the car is hidden behind door 3 and you chose door 1. Now Monty-Hall say, okay, look, I opened door 2. Look, there's nothing behind the door, there's a goat. Are you going to stay or are you going to switch? In this scenario, if you switch, you win, and you stay, you lose, right? Now let's look at the probability. Remember, the formula of the probability is the number of ways the event can happen divided by the total number of all possible outcomes. So the total number of possible outcomes is 3, 1, 2, 3. So the probability of switch and win is 2 on 3 because there are 2 ways switch will win. And the probability of stay and win is 1/3 because only have 1 way that you stay and win. So you better switch because you got a bigger chance to win the car. Now you probably found this slide confusing. Am I going to do with the cup? But I need to call Albert to come and help me to put back on the camera so you can see me on the screen. Albert! Can you please?
This was Skype.
Can you see me?
They're gonna talk though. Yeah.
Yes? Yeah, good. Now, okay, I got door 1, door 2, and door 3. And I got a car. And the other has nothing. You chose door 1, and the car's behind door 1. Now Monty-Hall say, look, I'm gonna open the door. Are you gonna stay or are you gonna switch? If you switch, you lose. If you stay, you got a car, right? So this case is stay and win. Now this time the car is hidden behind door 2. You chose door 1. Monty-Hall say, oh look, I opened this door, nothing behind this door. Are you going to stay or are you going to switch? This time, if you switch, you win. If you stay, you got nothing. So switch and win 1. And now the last scenario is the car is hidden behind door 3. You chose door 1. Monty-Hall said, okay, I open door 2. Nothing behind the door. Are you going to switch or are you going to stay? So this time, if you switch, you got a car. You stay, you got nothing. So switch and win twice. So you're going to have 2/3 of the probability. If you switch, you got a car. If you stay, you only got 1/3 of the probability. So you're better off switching than staying. It's a bit more clear? Okay, now I'm going to share my screen. This one.
Yeah.
Start sharing.
Yes.
Like that?
Yeah. Should be right now.
Should be all right?
Yeah.
Now let's move on to the different problem. Before I talk about the birthday problem, I need to introduce a rule of probability. What is the rule? The rule is the sum of the probabilities of all possible outcomes is 1. What does that mean? Let's have a look at some example. So when you're flipping a coin once, you might get a head. You might get a tail. So the sum of the probabilities of getting a head and getting a tail is always 1. So there are only 2 possible outcomes when you flip a coin, either head or tail. So if you add these probabilities up, they all sum to 1. Let's have a look at another example. When you roll a 6-sided die, what are the all possible outcomes? When you roll a 6-sided die, you might get a 1, or get a 2, or get a 3, or 4, 5, 6. If you add those probabilities up, it's always sum up to 1. So now let's look at another example. Rain tomorrow. The one possible outcome tomorrow is going to rain. And another possible outcome is no rain. Now be careful, no rain include sunny, cloudy, hailing, snowing, or all sorts of weather conditions, but just no rain. I don't care. So we only have 2 possible outcomes for tomorrow's weather, rain or no rain. So the probability of all those possible outcomes must sum up to 1. And if you are a student, you're going to have an exam tomorrow. You either pass this exam or you either fail the exam. So the probability for you to passing the exam or failing the exam must sum to 1. And if you are expecting your first child, well, there are only 2 possible outcomes for the sex of your first child, either a girl or a boy. So the sum of the probabilities of the girl or boy must add up to 1. Now I want to talk a bit about the birthday. So if you are in a room with some people, there are only 2 situations. That is, no one shares the same birthday in a room. The other possible outcome is at least 2 people share the same birthday. Well, here notice at least. What at least means? At least means either 2 people share the same birthday, or 3 people share the same birthday, or 4 people share the same birthday, or 5 or 6. I don't care. I know at least there must be 2 people at least share the same birthday. So there are only 2 possible outcomes. No one share the same birthday, or at least 2 people share the same birthday. So the probability of these 2 outcomes must add up to 1, right? Keep that in mind. Now we can move on to the birthday problem. Imagine that you you know, you are in a room having party with some number of people. How many people in this room that you can be certain that at least 2 people share the same birthday? Well, you might think there are 365 days in a year. There are 365 different birthdays. By intuition, you might think that there should be at least 365 people in this party that I can be 100% sure that at least 2 people share the same birthday. Is this correct? Do you need 365 people in a room that you can be 100% sure that they are at least 2 people share the same birthday? Let's have a look at it. So remember that before I talk about the probability of no one share the same birthday plus the probability of at least, remember, at least 2 people share the same birthday, they always add up to 1. We don't care about this. We care about what is the probability of at least 2 people sharing the same birthday. We can manipulate this equation a bit. We move this to the other side with 1. So the probability of at least 2 people share the same birthday equal 1 take away the probability of no one shares the same birthday, right? So if we can calculate the probability of no one shares the same birthday in the room, then we can get the probability of at least 2 people share the same birthday. So let's have an example. For example, you're having a big party with 99 people. That is, there are 100 people in total in this room. So the probability of at least 2 people sharing the same birthday is 1 take away the probability of no one sharing the same birthday. So let's have a look at no one sharing the same birthday. What is the probability of that? So let's start from the first person. I don't care which one is the first. Out of the 100 people, the first person can have a go. He can choose a birthday. How many ways, how many number of ways he can choose the birthday? He can choose 365, one day out of the 365 days, right? Because he's the first person to choose the birthday. So the probability for the first person to choose the birthday is 365 divided by 365. Now let's move on to the second person. Because the first person already chose a day, so the second person can't have the same birthday as the first person. So he only has 364 days left. He can choose one of those 364 days. So the probability for the second person to choose a birthday is 364 divided by 365. Now the first 2 people chose birthdays already. Now let's move on to the third person. The third person can't have the same birthday as the first 2 people. So he or she can have 363 days left. He can choose one of those 363 days. So the probability for the third person to have a birthday that is different from the first 2 is 363 divided by 365. So on and so forth. This is the 99th person. When is 99th person choose a birthday, the 99th person can't have the same birthday as the previous 98 people. So there are only 267 days left for this person to choose a birthday from. So the probability for the 99th person to have a birthday is 267 out of 365 days. Now let's move on to the last person, the 100th person. The 100th person can't have the same birthday as the previous 99 people. So he or she can only choose one day out of the 266 days. So the probability for the 100 people to have a birthday is 266 divided by 365. Now we need to multiply all this probability together because this should happen at the same time. They not happen at a different time. So we have to multiply. And we got the probability of no one share the same birthday. Then we can get the probability of at least 2 people share the same birthday is 1 take away the bunch of this thing. Let's have a look at the value. So for 100 people in the party, the probability of no one shares the same birthday is extremely low. It's 0.00003%. So the probability of at least 2 people sharing the same birthday is so high. It's 99.99997%. Let's have a look at the number. Here is a chart, a table, and a figure that I copied from Wikipedia. This chart shows you as the number of people in a room increases, what is the probability. So when there's only 1 person in the room, the probability of at least 2 people sharing the same birthday must be 0 because only 1 person in the room, there's no 2 people. So how can you have 2 people share the same birthday, right? So it must be 0. So when the number of people increase to 5 in a room, the probability of at least 2 people sharing the same birthday increased to 2.7%, a little bit higher. Let's look at when there are 23 people in the room. The probability of at least 2 people sharing the same birthday increased to more than half, more than 50%. It's pretty impressive. So as the number of people increased to 70, well, the probability of at least 2 people sharing the same birthday gone up to 99.9%, nearly 100%. So you can be 100%, nearly 100% sure that when you see 70 people in a room, there must be at least 2 people sharing the same birthday. Let's have a look at the figure. This figure basically just explains what's going on in this table. The x-axis represents the number of people. The y-axis represents the probability of a pair of at least 2 people sharing the same birthday. So when the number of people is 0, the probability is 0. When the number of people is 23, the probability of at least 2 people sharing a birthday is about 50%. So when the number of people increase to 70, the probability of at least two people sharing the same birthday is gone up to nearly 100%. That is 1. So this is what I wanted to talk about today. Probability is just a small part of statistics. I hope you found it interesting and fun and learn more about statistics in the future. Thank you.
Thank you for a very great presentation. Now we will start our question and answer sessions. I think the best way to do it is like if someone wants to ask questions, please send a message first on Skype, or you can also send a message on the WhatsApp group. I already changed the settings, so you are allowed to send a message there, so I know who wants to ask the questions, and then I will unmute them. Okay, or you can just also unmute yourself, I think, if you want to ask the questions. So feel free to ask any questions related to the presentations or statistics in general, or if you don't understand about certain part from Qin's presentations, please also do so. All right, anyone has a questions? Well, you can also ask other questions, like general questions you probably want to ask about PhD life from Qin's perspective, and like what kind of things that PhD students do every day. You can also do that if you want. Jadi kalau ada yang mau bertanya, silakan tanya saja pertanyaan umum, mungkin terkait studinya atau mungkin ada beberapa bagian di presentasi yang tidak dipahami, bisa silahkan ditanya. Kalau untuk bertanya, kalau tidak nyaman pakai bahasa Inggris, bisa bertanya pakai bahasa Indonesia, baru nanti bisa diterjemahkan. Kalau yang ingin bertanya, silahkan unmute pesannya, mikrofonnya, atau bisa juga lewat chat di Skype atau di grup, baru nanti disampaikan. Oke. Mungkin Ria ada mau menambahkan sedikit. Do you want to add anything else, Ria?
So far it's good, all good.
All right. Maybe Qin, could you tell us a bit about PhD, your PhD journey? Like, what do we need to prepare, and like what sort of stuff that you do every day in like during the office hours as a PhD students?
Yeah, pretty similar to your. I think if you want to become a PhD student, you really need to be interested in the topic, in the research topic you want to do. If you don't have the interest, you probably found 3 years and a half pretty boring, and you probably can't get through it. My PhD research is in statistics, basically in model selection, in phylogenetics, and I really enjoy it. So far so good. Only in my first 3 months. I found that honors year is very crucial for my PhD year because I learned how to do research independently and how to write a thesis. Every day I basically just do what my supervisor wanted to me do and read papers and do some simulation of data, analyze the data, and probably if I stuck on a particular problem, I want to solve it by myself first, independently. I think the most important thing you learn from PhD is you have to solve problem independently by yourself rather than just to ask your supervisor or ask other people. If you really stuck, probably the second option is to ask your ask your supervisor. And I don't know what your background is. You might be a university student and might thinking about doing PhD. I think it's a really good choice if you interested in some particular area. For me, I really like statistics. I just found it really fun, and statistics is all about data. You can collect the data and you can get the information from data. You can make inferences, make decisions based on the data. It's just really cool, and every area needs really needs statistics in every area, medicine, weather forecast and phylogenetics and physics, chemistry. I haven't seen now any area they can live without statistics. So if you're interested in statistics, go ahead to do statistics. I really encourage you to do that.
Thanks, Qin, for the answer. So everyone, I think some of you are not familiar about what honors years is. So maybe I'll just give a bit introduction to honors degree here. So it's basically the same if you having your higher degree in Indonesia, because university students in Indonesia need to do research in their last year of the university life. So basically honors years like another 1 year for students to do research, independent research under guidance of their supervisors. So here in Australia, university students are not required to do thesis, to do research. If they only prefer to take courses, they can. But if they want to do research, then they do honors. Most students, if they already did their honors year, they don't take master's degree, but they jump to the PhD degree. So it's not common in Indonesia, I know, because usually we do from bachelor going to master's and then to PhD, right? Okay, Qin, could you please talk about a little bit about phylogenetics, because you mentioned about phylogenetics, like how do you apply statistics, like your model, your statistical model to phylogenetics?
I think probably most people have no idea what phylogenetic is. Phylogenetic is the study of study the relationship between species. So you got some DNA data from different species. For example, we got DNA data from human, or from a monkey, or from a chimpanzee. We want to build a tree, a phylogenetic tree, just kind of like family tree, to show the relationship between a monkey, human, and a chimpanzee. So which group, which two species or three species can group together, and we want to make a tree with branch length and where the roots are, and find out the ancestors stay. So there are many models that can be used in phylogenetics, but which model is better? So my research is solving this problem, try to find a way to select a better model to be applied in phylogenetic setting. I feel like this is a very interesting topic for me, because I've been doing statistics for years. I got my bachelor degree is majoring in mathematics and statistics, and they got so many things can look at in model selection and phylogenetics. Oh yeah, is someone ask me a question?
Yes.
I couldn't see, sorry.
Yes.
Yeah, someone
yeah.
ask me the Monty-Hall problem. Scenario 1. Oh, the card dropped, sorry. So here, can you see? I got door 1, door 2, and door 3. Scenario 1 is the car is hidden behind door 1, and you always chose door 1. So the Monty-Hall say, okay, I'm going to open one of these doors. See, nothing here. Are you going to stay, or are you going to switch? So if you stay, you stick with it, you win, right? If you switch to here, you lose, because there's no car behind door 3. So scenario 1 basically means you stay, you win, right? Is that clear? Do I answer the question?
There's I think Harun also has a question.
I can't open the conversation. Okay.
Yeah, so I think his question about this. I think the person is doing epidemiology, and then requires some statistical tools and
oh, epidemiology. Oh, yes.
study. And then what do you recommend for me to study? I think, okay, so he's currently doing public health for bachelor's degree and want to advance to higher in the area, and then probably need some statistical. Do you know, like in Australia, where in Australia do you think is the best, like the best university for field in public health? That, you know, computational stuff. I'm pretty sure.
I don't really know, but it's really great area. Statistics can be part of the I don't know how to read the word epidemiology. Is that kind of you know, coronavirus things, like the disease, spreading of disease? Hi, Albert.
Right. Oh.
Is that what epidemiology means?
Yeah. Area.
I think it's really good if you can study statistics in the epidemiology. I don't know how to read it, but I can show you an example, like coronavirus at the moment. if we can have a good model for my area, I can select a good statistic model to analyze coronavirus DNA sequences, and we can get, for example, some similar virus sequences like SARS or any other flu DNA sequences, and we can line them up together. If we got a good model to review this relationship between these different viruses, we might help the doctor and expert to develop vaccine quickly and effectively and use in public. And we could have stopped this spread of coronavirus. I don't know where you could. I recommend you can come to Australia and study. I think Australia have a quite good university if you want to study in this area. And you probably should learn a bit more about statistics if you want to do further study, because I think statistics is very essential for every area. Are you happy?
I think Martha also wants to ask questions. Martha, do you want to ask the questions to Qin? Hello? Hello?
Hello. Okay.
Yeah.
Hello.
Hello.
So we're speaking now?
Hello.
I can hear you. Hello.
Can you hear me?
Yeah, I can hear you. Yeah.
Hello. Chi.
Hello.
I want to ask you. I know that you're a PhD student and you have family, you have children, and I want to know how you manage your time, how hard it is to have your PhD life, and also need to take care of your family as well.
Yes. Yeah, obviously you have family as well and you want to study PhD?
I'm sorry?
I think it's more about you, like
More about me. Okay,
how
yeah.
do you manage your time, like between doing PhD and then you also have family?
Oh yeah. Basically family is first, number one. PhD is just my hobby. I don't put PhD, I don't put study first. I put my family first. And my children, I got two children, two daughters. One is 9, one is 7. They're at school from 9 to 3 every day. And I look after them 3. Okay, so I got a question. Anyway, I'll answer how I manage their life. It is pretty hard, but if you determine to do it, you can do it. And yeah, and I think I just been studying so many years. I studied when my first child was born, 2010, when she's just a little baby. I looked after her full time, breastfeed at nighttime and got up at 5, got up multiple times at nighttime to feed her. I still remember those difficult times. Those difficult has gone. And now I found it's actually easier when they're a bit older. So I don't think anything can stop you if you determine to do something. And I determined to do a PhD. And that's just me. I don't know about, if you're interested enough, I'm sure no matter what, nothing can stop you from finish your goal. Yes. I think I saw questions. I'm going to open the conversation.
Yes, there's a question for Maria.
Oh, yes.
Yeah.
Okay, I got it. So from those 3 scenarios, Monty-Hall can choose first, and we just can choose between stay or switch. No, you chose first. When you choose first, you chose which door. Then Monty-Hall can choose between the rest of the door, because the Monty-Hall know which door has a car, which door has no car. So based on your decision, Monty-Hall decide which door to choose. That's why he injected this new information into this problem. So if he didn't open the other door, basically your winning is 1/3, because you chose the door, you open it, win or lose, you only have 1/3 the chance to get the car. But once Monty-Hall opened another door, he actually injected the information, the new information into this problem, and it made the probability is not 1/3 anymore. So if you stay, you only have 1/3 chance. If you switch, you have 2/3.
Okay.
Is that clear?
Yeah, it's clear.
Yeah, good.
All right, thanks.
Yes.
Thanks. Anyone else has a question? We still have
Yes.
like, I think 15 minutes before we end this discussion. So if you still have questions, any questions left, please just ask. Really, do you have a
Hi, Qin.
Okay.
Hi.
Thank you for the presentation. It was really great and very informative. I'm so happy to learn from you.
That's
I've
good.
got a questions regarding how to find the supervisor in the universities in Australia. Could you share with us your experience when you are looking for the supervisors there?
Yeah, basically my PhD supervisor are also my honors supervisor. So I've been doing honors with them. The most important thing is you have to your personality has to be compatible. You can't be clash with them, and so you have to work with them. They have to work with you. It's a both way. And you need to find a supervisor that have the knowledge to guide you through your research. So it's 3.5 years is a long time. So supervisor is very, very crucial, and you got to make sure they're going to stay in the university during your study. If they leave, it's going to be devastated for you. So in regarding how to choose supervisor, I think you just have to look around to see which supervisor has the knowledge first, and then physically have a face-to-face talk to them and see whether you get along well with them and you think he's a nice person or she's a nice person, and go from there. I think it's very important to have a good supervisor, that they are really the main support to guide you through the difficult 3.5 years.
So, did you like send them an email about proposing to be their under their supervisor, or did you just apply through the university websites for the supervisor? Because I've been looking around the supervisors for my PhD, but I'm a little bit afraid of sending them an email for like proposal emails, because I don't feel like I'm well prepared enough. So yeah.
Yeah, I understand how you feel. It's always daunting when you want to send email to someone that you thought, oh, they might be tease me or they might be laugh at my silly project. Oh, don't be afraid. I think I've seen lots of this. You are a student. If you're really interested in doing a PhD in an area, you just go and ask to say, hello, my name is what, and I want to do something in my PhD. I was wondering whether, my proposal is okay don't be afraid to ask. There's no stupid question. And for me, I just look at because I live in Hobart, my family's in Hobart, I don't want to move out of the Hobart. So I did a distance bachelor's degree through other university, and I want to continue my honors. So I actually looked through University of Tasmania, because only one university in Hobart. So I want to do statistics. I really want to do statistics. I don't want to do anything else. But only one lecturer can be a supervisor in statistics. And that's how I found my supervisor, Barbara Holland. I really like her. It's so lucky we get along so well. And she's now professor, and she's also my PhD, one of my supervisor in PhD. But I just went to see her when I sent an email, I said, can I talk to you? I went to see her, and then we talk about the potential project with my honors. And, back then I not really have any clear idea what I want to do in my honors. That's fine. You can work through it. You can talk about it, something that you're interested. Actually, I changed my project halfway through my honors because my project fell through, and it's all panicking. And, that's all fine. Just make a first step. And don't be afraid. Yes.
Thank you. And last question. How long did you wait to get the information about the, about the confirmation from your supervisor? How long did you wait? Did you have to
Oh,
wait for
I don't
one?
need to buy actually. I think normally, I don't know how many. Albert probably can answer you the question because I'm graduate honors here. So just straight after, just even before I graduate from honors, I just say to my supervisor, I want to do a PhD. She said, great, I drafted a proposal for you. And we just apply scholarship straight away. I got it in a month scholarship. Just straight after I finished honors, I straight into PhD. I think
Oh,
Albert probably can answer. Yeah,
that's so fast.
I know.
I
Thank
think
you.
it depends, like it varies across students. If you like have currently just finished your master's, say just finished your master's say in Australia at the same university, and then you want to apply for the scholarships from the same university for your PhD, that would shorten the amount of time you need to wait before you get a scholarship and to commence your study. But if you like say have finished your master's or your previous studies some years ago and then you wanna continue your PhD, I think that will take a longer time for you. Yeah. So like in my case, I need to wait for some months first. But in Qin's case, she didn't have to wait too long for that because she just applied for the scholarship straight away after she completed her honors degree. So yeah.
Thank you, Albert.
Yeah.
Thank you,
So
Kian, for answering my questions. For others, do you guys have any other questions to be asked? Feel free to ask in Bahasa or in English.
yes. So we still have like I think 8 minutes, around 8 minutes left. If you have questions, just let me know. Just let me or Ria know or Chin know about your questions. Uh, just a short announcement. So this is the first webinar for the project for class starting IELTS entity. We already have a plan for the second web seminar. It's not scheduled yet, but we already have speaker that want to share about a topic. So I think the next webinar will be about strategic studies. So the person will discuss about some policies in Indonesia that are related to the nation's security. So yeah, and she has degree in strategic studies from Australian National University and currently working as a lecturer at a university in Indonesia. And he would like to share about the topic that I just mentioned earlier. But we'll keep you guys posted about it. So just follow our social media in Facebook or in Instagram or in Twitter, and then we'll make sure that you know about that once we already have the schedule. So yeah. Anyone else have questions? Yeah, I think someone's typing, but if you just want to talk, that's all right. If you wanna ask questions in Bahasa, that's all right too, because we can always translate your questions. So you don't need to type your questions if you prefer.
Oh yeah,
Oh,
it's
yeah, there's questions.
Yeah, so questions. I'm a civil servant of environmental institution in Kompang City. I want to study environmental science, especially how to handle environmental data. Can you explain me about what part of statistics I have to know related to the subject? Well, handling data. You probably have to learn how to do data handling first. And you probably need to learn models because you need to use a proper model to review or to infer the relationship between those data and what actually it really depends on what type of data it is. You need to use different models. So you need to learn data handling, you need to learn software to analyze the data, and you need to learn the models, you need to learn how to select the model and all sort of thing. I don't know, you probably should want to do some statistic course. I don't know, you got some in Indonesia, like university or just some free online course. Albert, do you have any university provide statistic course?
Yeah, it's quite difficult in Indonesia because like our system, our university system doesn't allow students to take courses from different colleges. So if you are like in public health faculty, then you can only choose courses from that faculty and not other faculties. But you can always enroll in online courses. Like I believe some of them are free. I think
Yes.
Ria knows more about online courses, like maybe some website that provide free online courses.
So yeah, there are lots of online courses which are free, and also you have to pay a little bit charge. So at the moment, if you want to go for the online course which is free, you can go to this website. Hang on, I'm gonna type it and keep it on our chat so you can actually. So here, just go to canvas.net. They provide a lot of online courses given by lots of universities abroad. And I currently also take the statistic class at the moment. Yeah, and then some courses have like a time limitation, so you have to take it for 1 or 2 months. But some are self-paced, meaning that when you start joining the online course, you can take as much time as possible to finish the course. So that one is free. The other one here is Coursera.com. Hang on, I'm gonna just send you the website name here. But Coursera, unfortunately, is not free. You have to pay. You have to pay maybe $10 or $15 for a package. But some courses in Coursera are also free. The thing here is that you just have to look for it, and then you have to just like sometimes on the websites they will notify it whether the course is free or not. If it is free, then you can actually join them, but if it is not free, then you have to pay some coins to join it. And another one here is future. Hang on here. So this one as well. Actually, I use this Future Learn online courses to learn about IELTS. So if you want to learn about IELTS or other courses, just go to that websites, and then there are lots of university that offer online course as well. So these are 3 online courses that I recommend you guys to follow. But at the moment, I joined this online course in Canva. And I did some online courses from Coursera as well, and from Future Learn. And at the end of the program, you usually get the certificate, the online certificate, and also if you performed well on the online courses that they are provided, you usually get some other extra badge for the appreciation and stuff. So yeah, go have a check by yourself.
Thanks, Ria. So you can have a check on those 3 websites that Ria has provided. So I think this is the end of our discussions today, this afternoon. Thanks everyone for joining this session. we hope that the sessions with Qing was useful for you and beneficial. And stay tuned for more information from us. Okay, thank you. Enjoy your weekend.
Bye, Kin. Thank you very
Bye.
much. Bye,
Happy
everyone.
International Women's Day.
Yeah.
See ya.
Bye. See ya. Thank you, everyone.
Yeah.